Advanced Math Lesson 50, Trigonometric Equations. These sound harder than they actually are. They're pretty simple. We just have to do a little bit of rewriting before we start doing some trigonometric functions we've already been doing. So let's go ahead and we're just going to jump straight into an example. So they're going to give you an equation. They'll tell you to solve this given this domain. We're solving for theta. Sometimes they'll put x, a lot of times they'll put theta. So what we're solving for in this equation is theta. We want to find the angle. The equation is set equal to 0. And so we need to rewrite it to where the only thing on one side is secant and theta, or our trig identity and the unknown. So let's go ahead and use some rules of algebra. First thing, I'm going to use PEMDAS backwards, so I'm going to move this whole number 2 by subtracting on each side. Cancels. So now I have root 3 times the secant of theta equals negative 2. Next, I'm going to get rid of the square root of 3 through division. So divide each side by root 3. That cancels. So now what I have is the secant of theta equals negative 2 over square root of 3. Again, so just using algebra to rewrite this. And now this is a problem we've seen before. So we have to find the secant of theta at negative 2 over root 3. And then I have this domain saying that theta cannot be must be greater than or equal to 0 or less than or equal to 360. So theta is going to be somewhere between 0 and 360 degrees. So let's go to secant. Secant is another way of saying 1 over cosine. So 1 over cosine of theta is going to equal negative 2 over root 3. I can flip this by inverting both sides. So the cosine of theta is going to equal root 3 over 2, or negative root 3 over 2. And then I can use reference triangles, or I can consult my unit circle. So where is cosine negative root 3 over 2? Let's see here, all positive. Cosine can be negative here. Cosine can be negative here. It's not going to be negative here. So I'm looking at the second and third quadrants. And again, I'm looking for negative root 3 over 2. And the cosine block. And I've got it here and here. So I've got two locations. Cosine is negative root 3 over 2 here, and it's negative root 3 over 2 here. So I've got two answers. My answers are 150 and 210 degrees. So theta is going to equal 150 degrees and 210 degrees. And that is my final answer. And trigonometric equations are that easy. That's all it is. We'll do another one right now. So they want me to solve 3 root 2 plus 3 times the cosecant of theta equals 0, given the domain of theta being somewhere in between 0 and 360 degrees. Again, rules of equations. I'll start out by moving this 3 root 2 to the other side, so I'll subtract that from both sides. Now I have 3 cosecant of theta equals negative 3 root 2. Again, divide each side by 3. It's going to cancel. So now I have cosecant of theta equals negative root 2. Here I'm going to rewrite this. Cosecant is 1 over sine. So 1 over, whoops, this is 1 over CO. 1 over sine of theta is going to equal negative root 2 over 1. To invert it, I'll just flip both sides. So then sine of theta is going to equal 1 over negative root 2. I'll go back to my unit circle. Let's see here, sine is not going to be negative here. And sine is positive here and here, so my options are going to be here and here. All students take calculus. I'm going to look here and here for negative sine, and I'm looking for negative 1 over root 2. Excuse me. I just remembered we have to rationalize the denominator here. Multiply each side by root 2, so that's going to become root 2 over 2. So negative root 2 over 2, so that's what I'm looking for. I look down here, and I've got sine at negative root 2 over 2 at 225 degrees. And again at 315. So 225, 315. And that's going to be a trend you'll see for these problems. You're going to see that theta is going to have more than one answer. So in this case, it's 225 degrees and 315 degrees. That's it for trigonometric equations. Probably the shortest lesson or shortest video I've done in a while for you guys. At any rate, if you have any questions, let me know on Moodle, and I will see you in class.